So in our previous lessons, we have studied vertex form of quadratics. We have also studied standard form of quadratics. And now we're going to consider factored form of quadratics. So if I give you a quadratic that looks like this, y equals x squared plus 7x plus 12. We can factorize this to find the factored form of this quadratic. So it's in standard form. When you go through the steps of factorizing, you will get x plus 4 times x plus 3. So these are the two binomials that you multiply to get x squared plus 7x plus 12. If we want to find the x-intercept, because that is one of the key features of factored form, you can easily identify the x-intercept or the zeros of the quadratic. We know the x-intercept, the y-coordinate value is 0. So when I plug in 0 here, I would get 0 equals x plus 4 times x plus 3. Now if I use the zero product property, remember what the zero product property says. You're multiplying two things, a times b, and your answer is 0. So either a has a value of 0, or b equals 0, or both a and b equals 0. So in this case, x plus 4 could be equal to 0, or x plus 3 could be equal to 0. So the values of x would be, when we saw these equations, we would get x is equal to negative 4, or x is equal to negative 3. So those are my two possible zeros for this quadratic. Now if we were to put this on a graph, this is what it would look like on a graph. So let's go ahead and sketch this. So I have an intercept at negative 4, and I have another one at negative 3, and this is not drawn to scale. We know the graph of the equation is y equals x squared plus 7x plus 12. So my graph A is 1, so my graph is going to open upwards. It's going to look something like that, pass through, and it's going to go back up like that. So my two zeros are at negative 4 and negative 3. What that means is, if I have y equals x plus 4 times x plus 3, if I plug in negative 4 in the equation, I would get negative 4 goes here, so that would be 0 times negative 4 plus 3 is negative 1, and that gives me 0. Or if I plug in x equals negative 3, that would mean that I would have negative 3 plus 4 is 1 times 0, and that would also equal 0. So these are the two numbers that when you plug them into the original equation gives you a y value of 0. What you should also be able to do in this lesson is to identify which part of the graph is positive or negative. So I give you this, you need to figure out where is it going to be negative, where is it going to be negative, between what intervals. If you know the intercepts, you can take the intercepts, x-intercepts, put them on a number line. So I have negative 4, I have negative 3. You can now check a point in this section. So the two x-intercepts divides the graph into 3 equal points. 3 points rather, 3 sections. I have a section here, I have another section there, a third section. Plug in a point in this section and see if your answer is positive, which means at that point the graph is above the x-axis, it's positive. Or if you get a negative value, the graph is below the x-axis, it would be negative. Do the same for these other two sections. So let's plug in a number in this section. Let's plug in negative 5. So here's my equation, x squared plus 7x plus 12. I'm going to plug in x equals negative 5. So negative 5 squared is 25. Negative 5 times 7 is minus 35 plus 12. That's 37 minus 35, y is equal to 2. So the graph is positive. It's going to be somewhere up here when x is equal to negative 5, which we already know is true. Because at negative 5, we know we have positive values. Let's plug in a number here in this section. Let's plug in, say, negative 2. So again, the equation is x squared plus 7x plus 12. Let's plug in negative 2. Negative 2 squared is 4. 7 times negative 2 is negative 14 plus 12. That gives us 16 minus 14, also equal to 2. So when x is equal to negative 2, I get a positive value. My graph is positive for all values greater than negative 3. It's also positive for all values less than negative 4. And of course, between negative 4 and negative 3, that section of the graph would be negative. The final thing you need to learn or to be able to do in this lesson is, if I give you 3 points, I want you to be able to write the equation in factored form. And the general format for factored form is y is equal to a times x minus q times x minus p. Let's use some coordinate points. So let's plug in negative 2, 0, negative 1, 0, and negative 3, 20. Let's plug in the x coordinate points here. So I'm going to plug in negative 2 and negative 1 for p and q. So if these are my zeros, I'm going to plug in y is equal to a times, and this becomes x plus 2, and then this would be x plus 1. And we know if these are our zeros, when we say x plus 2 equals 0 and we solve, we get x equals negative 2. If one factor is x plus 1 equals 0, it's a 0, then we know x equals negative 1. So that's why we're using those 2 points there. So we've used the 2 zeros. I'm now going to plug in the third point using the x and y values so I can determine the value of a. So I'm going to use this third point now. So I use those 2 for the zeros, and I'm using this to find the value of a. So I'm going to plug in y is equal to 20. A we don't know. X is equal to negative 3. So when you plug negative 3 in here, negative 3 plus 2 is negative 1. Plug in negative 3 here. Negative 3 plus 1 is negative 2. So that gives me positive 2a. So 2a is equal to 20. A is equal to 10. Hence, my equation now is, the format again is a, x minus q, x minus p. That would give me a is 10, and this was x plus 2, x plus 1. So this is the quadratic equation in factored form that passes through the 3 points, negative 2, 0, negative 1, 0, negative 3, 20. So I hope you learned from this video how to write equations in factored form, and also how to factorize and use those zeros to determine whether the graph is positive or negative.